When I feel this much cold on the outside of the freezer, I know that the insulation is really not as thick as we would like. Oh, what have we here? Climate change is a problem we don't need to have, and it's cheaper not to.
For Amory Lovins, solutions start with efficiency, reducing the use of energy that produces CO2 emissions.
Do you see that little red light down in the corner?
Yes.
And this whole entertainment center goes through one plug, so I'm going to plug it in through the meter now.
If you have all kinds of appliances, you know, your TV, your VCR, your DVD, etc., that have that little light on,
yes,
they're using electricity. It's called vampire loads.
109 watts, almost $60 a year just sitting there turned off.
Lovins doesn't just talk the talk. He lives in a house he designed without a furnace in Aspen, Colorado, where temperatures in winter routinely drop below -17 Celsius.
We're at 7,100 feet here. It can go to -47 F, get frost any day of the year, and we can get 39 days of continuous midwinter cloud.
Lovin's house is a mix of high technology and homespun common sense. Solar units on the roof produce more electricity than the house uses. The entire house runs on just 120 watts, slightly more than a single light bulb.
Energy efficiency is the biggest, fastest, cheapest way to solve the climate problem, to save money, and to make a safer, richer, fairer, cooler world.
Next to our homes, the second largest source of emissions we're responsible for is parked right outside. Cars produce nearly 20% of global greenhouse gases. To keep warming below the critical 2-degree threshold, we need to cut 7 billion tons of greenhouse gas emissions every year. Doubling the average fuel efficiency of all cars from 25 kilometers per gallon to 50 would save 1 billion tons. But we would still need to cut billions more from our carbon footprint to stay on the safe side of +2 degrees.
We have an arsenal of solutions already. It's going to be solar, and it's going to be wind, and it's going to be tidal power, and it's going to be thermal power. All of these different things working together actually give us a pretty good ability to get away from the fossil fuel economy.
The ultimate answer may be just over the horizon. But the problem continues to grow. With each passing year, we consume more energy. The future will test the best minds in science. An international team of physicists in England has already started attempting the mother of all technological solutions, nuclear fusion. They're building a fusion reactor modeled on the single best power plant in the solar system, the sun. Harnessing that same power could mean a virtually limitless and self-sustaining source of energy without producing any greenhouse gases.
This energy lights up the universe, powers most of the stars in the universe. So what we're trying to do here is to replicate the same process on Earth and use this amount of energy to produce electricity.
It won't be easy. The core of the reactor will be nearly 10 times hotter than the sun. A powerful magnetic field contains the superhot plasma and prevents it from melting through the reactor's walls. Even if it works, and there's no guarantee, the reactor won't produce commercial electricity for at least another 30 years. As ambitious as it may be, fusion may appear relatively down to earth. Imagine outer space filled with a cosmic fleet of mirrors. One current research project estimates that 1 million mirrors, each about 3 feet across, could block out enough of the sun's heat to lower the Earth's temperature.
It's no good sitting around hoping that someone's going to invent some fantastical new source of free energy. The reality is we have to deal with what we've got, and we have to do it within 10 years.
The world's appetite for energy remains voracious. Our carbon footprint is staggering. As global warming escalates, it also accelerates. At some point, climate change could take on a life of its own, and global warming would become a runaway train. The only question is, now that we know about it, what are we going to do? Even the worst-case scenarios of 6 degrees won't mean the end of all life on Earth. But the planet after extreme global warming would be radically different from the life we know today. How bad could it get? At that point, the best minds on Earth agree on 2 things. They just don't know, and they hope we'll never find out.